Right, so yesterday we left off on subsets. Then I told you that there are actually two types. We've got our proper subset and then we have our subset. So just to recap, if every element inside set A is inside set B, everything in set A is inside set B, we say that A is a subset of B. So that is quite logical to us. It's a subset. Now, if A is a subset of B, but A is not equal to B. So when does that happen? Everything inside A is inside B, but A is not equal to B. Then we say it is called a proper subset. So let me give you an example. Your pencil case. We consider your pencil case as a set. Everything in your pencil case is inside your bag, right? Right? So we say that your pencil case is a subset of your bag. So far logical? Right? Everything in your pencil case is inside your bag. So your pencil case is a subset of your bag. Question. Is your pencil case equal to your bag? No, right? What else does your bag have that your pencil case doesn't have? Huh? Books, your phone, so on and so forth, right? Therefore, your pencil case is not equal to your bag. And therefore, we say that, hey, your pencil case is considered to be a proper subset of your bag. It is a proper subset because although everything is inside, they are not the same. Okay? So when we have a case of a subset that is not a proper subset. A pencil case is inside the same pencil case. So effectively it's like everything in that pencil case is inside another pencil case which doesn't have anything else. These two are the same. Two equal sets. They are equal inside each other. So that is a case of subset. Okay, we will understand a little more as we go on. Okay, so we also talked about what this symbol over here means. It means it is not a proper subset. Okay, now consider the following set. We've got set C, we've got red and green. Set D, red, yellow, green, blue, and so on and so forth. Now we can see that set C is a proper subset of D. See, everything found inside C, your red, your green is found inside D, right? So we say that C is a proper subset. Everything is found inside, but they are not the same. Get it? Next, let's look at E. Set E contains integers. Set F contains rational numbers. So rational numbers, we've got our integers, we've got our fractions, decimals, so on and so forth. So everything found inside E is found inside F. So E is a subset. However, not everything in F is found inside E. So we term this as proper subset as well. And then we come to the last case. Last example over here. We've got set G contains male and female. Set H contains female and male. Question. Is everything inside G found inside H? Yes, right? So we say that G is a subset of H. The symbol for subset looks like this. Okay, but is G a proper subset of H? Is it a proper subset of H? Proper means they are not the same, not equal. Like your pencil case is not equal to your bag. That is a proper subset. In this final example, G and H, they are exactly the same. So we say that it is simply called a subset. In fact, they are equal. But we cannot say that they are proper subset. Okay? So let's look at example number 5. So why is it not proper? Because they are the same, they are equal. See, G and H are equal to each other. If they are equal, they are not proper. Okay, you can write this down. If the sets are equal, then they are not proper. Okay, so this is a note that you can write lah. Once it's equal, it's not proper, no longer proper subset already. It is only considered subset.
So subset is also equal.
Subset, okay. So you see this symbol here for subset, right? Does it remind you of something? Does it look like an inequality to you? No, man. You know this less than symbol? Right? When I say x is less than 7, then x could be equal to, for integers, like integers only, so 6, 5, 4, and so on, right? And then when I say x is equal to 7, I've got x equal to 7 lah. But when I combine x less than or equal to 7, then I'm taking all these results, 7, 6, 5, and so on, right? So this symbol over here, with that little extra line at the bottom, it just means we are combining an equal case with the inequality case. We're combining the results. We bring back to this. Proper subset, symbol looks like this, proper. Equal subset has this symbol, equal sign. You combine them together, you get subset, which is like this. That's one way you can think about it also.
Actually, subset is the same as equal sign.
Subset,
It's the same as equal.
just like saying, hey, is this inequality sign the same as equal? No, it is actually equal as well as less than. Right now. So our subset symbol got two options. Maybe it is a proper subset, maybe it is equal. Okay, example, express A by listing elements. A is a root. Root just means solution. A is a solution of x squared minus 4 equal to 0. Okay, a solution of x squared minus 4 equal to 0. We can solve that. X squared minus 4 equal to 0, we got x equals to negative 2 and 2. Meaning there are only two elements inside set A. They are negative 2 and 2. So that is this format is called listing. Whereas now in set B, we only have one element 2. Set C has three elements 1, 2, 3. So part B, why is B a proper subset of set A? To answer that question, look at the elements inside B. Are they all found in set A? Are all the elements in B found in set A? Yes, they are. There is only one element in set B. So 2 is the only element in B and it is also in A. This fulfills condition for subset. Just subset only. But the question says proper. Okay, now we carry on. The element negative 2 is inside A, but it is not inside B. In other words, this chunk is telling us A not equal to B. Then because A is not equal to B, B is now a proper subset of A. Take some, let it sink in. If everything inside B is inside A, it means that B is a subset of A. But the question is asking for proper. So we need to carry on to say that they are not equal. That is why we conclude that B is now a proper subset of A. They are not equal. Need logic one. Anybody else? Raise your hand. Okay. This is called a Venn diagram. I'm going to be drawing a Venn diagram. Set A looks like this. It's got a negative 2 and 2. Negative 2 and 2. Right? What about set B? Set B only has one element 2. Right, Javier? Where should I draw my set B? I'm drawing a Venn diagram. You ever seen Venn diagrams like this before? No, huh? Okay. So basically, this big circle, right, is called represents a set, and it is called set A. This set has two elements inside, -2 and 2. You can see that? And then there is another set called B. Set B, one element only. It is 2. Has 2 already appeared over here in this diagram? Have, right? B, this one over here. Do you understand what's happening so far? I just drew set B inside set A. Do you agree? Now, set B is found inside set A. So we can confidently say that set B is a subset of set A. Visually, does it make sense? Now, question. Is set B equal to set A? No. Okay, then we have the answer already. Because it is not. Because they are not equal. So from here, I conclude that B is a proper subset of A. When I say proper, it means that it is entirely inside but not equal. Okay, so what is an example of a subset that is not proper? A subset that is not proper. I'll give you an example. Let's have X. Inside this set, I've got 1 and 2. Now I draw another set. This is set Y. What does set Y contain? 1 and 2. Are all the elements in set Y found inside set X? Yes, right? So I can say that Y is a subset of X because everything inside Y is found inside X. However, are X and Y actually exactly the same? Is set X and set Y actually the same? We decide based on the elements. Do they all have the same elements? Nothing more, nothing less. It's the same, right? So, in fact, X is equal to Y. So, the first line says that Y is a subset of X. The symbol looks like this. Y is a subset of X. But to be more precise, X is equal to Y. Y is equal to X. Both ways are the same. This is a case of subset that is not proper. A subset that is not proper implies that, therefore, X equals to Y. Okay? You have to know the difference between proper and just a usual subset. A normal subset just implies that it could be proper, it could be equal. Okay? Okay, now is A a proper subset of C? A, is it a proper subset of C? Answer is no lah, because A has this -2, but C doesn't have -2. So the presentation is that A is draw a proper subset symbol and you just put a dash. It's not a proper subset of C. Any questions? I think you don't need to try lah. You all need to try? Okay, then let's try it. I'll give you 1 minute to do try 5. Universal set and empty set. Actually, it is literally what the name says. Universal set contains everything. Empty set contains nothing. Okay, so there is let's look at an example easier to understand. So suggest a universal set for each of the following. So set A contains carrot, cabbage, celery, and lettuce. So what could a universal set be? So this symbol over here, you have to learn how to draw it. This funny looking letter E, like this. Something like this. You show me something like this, it's good enough. Okay? So go and practice. Just try to do it nicely. I also cannot do it properly. Go and practice. So this is a symbol for universal set. So the universal set is just vegetables. And then A is now a proper subset of the universal set, because A is found inside this universal set called vegetables. Set B contains 2, 4, 6, 8, 10. A suggested possible universal set is that X is an even number. So based on this, we can say that A is a proper subset of the universal set. Based on this, we can say that B is a subset of the universal set. Proper subset. They are not equal, but found inside. Okay, so suggest a universal set for Q. So part A, Q, the universal set could be tools, for example. And then for part B, the universal set could be odd numbers. Such that Q is found inside the universal set for tools and R is found inside the universal set for odd numbers. But they are not equal. These are only limited elements. Okay, so next, when a set has no elements, it is called an empty set, as I mentioned. Nothing inside means it's empty set. But empty set is still a set, right? Your pencil case, even if it contains nothing, is still a pencil case, right? Your pencil case, even if it contains nothing, is still found inside your bag, isn't it? Right? Okay, so you have to take note of this. An empty set is still a set. It's just that it has nothing inside. Okay, so the symbol for empty set, it looks like this. Very easy to draw. Circle and one line down. Nothing inside. So, the set, men who are taller than 5 meters. Is there any man who is taller than 5 meters? No. There are no elements inside this set. Okay, the set exists, it's just that there's nobody inside. There's no element inside. Next, x is a real number, and then x squared plus 1 equal to 0. Can this be true? X squared plus 1 equals 0. Let me try and solve it. X squared equals to negative 1. I want to square root both sides. X equals to plus minus square root negative 1. Can or not? Cannot square root negative, ma? No solution. For this set, the set exists, but there is no element inside. This is an empty set. Get it? A real number, all the numbers that you know so far, they're all real numbers. The opposite of real numbers are imaginary numbers, which you haven't heard of yet. You haven't thought about it before. So just take it that all the numbers you know are real numbers. Okay? So now we end up having this very interesting situation. An empty set is still a set, although there's nothing inside. It is a proper subset of A. Does that make sense? So let me draw you a Venn diagram again. This is my set A. Okay, set A has some stuff inside. But now I draw an empty set. Does the empty set exist inside set A? Can I have an empty set inside set A? Can, of course. It is an empty set, what? There's no element inside. I can place my empty set inside any set. Don't worry about it. It's empty. It doesn't affect anything. So an empty set is always found inside any set. And guess what? Any set A is found inside the universal set. Does that make sense? Any set in the world is found inside its universal set. Why? Because it's called a universal set. Anybody lost? Raise a hand. Lost? Okay, we go with the empty set first. I think empty set might be a little easier. Empty set just looks like this. Okay, work with me. Let me continue think with me. What is inside this empty set? Nothing. There's nothing inside. For a set A, for example, which contains 1, 2, and 3. set A contains 1, 2, 3, is all the elements inside the empty set are all elements in empty set found in A? Question mark. Why not? Why not? What are the elements inside empty set? There's nothing. So is the nothing found inside set A? Why not?
Yes. A have 1, 2, 3 is not nothing.
A have 1, 2, 3, it is not nothing. Yeah. But empty set has nothing. Is the nothing found inside the set A?
How is the nothing found? Let's say A have something, then it's not nothing.
How should I put it? You can try? You can imagine. Okay, let's take your set A as your bag. Okay, your empty set is your pencil case. Pencil case containing nothing. It's an empty pencil case. I put the empty pencil case inside your bag containing books and stuff. Does the empty pencil case affect the elements found inside your bag? Pencil case is not element, pencil case is a set. If I put an empty pencil case inside your bag, are the elements of your bag affected? Yes or no? One more time, slowly. Some haven't get it yet. Pencil case is not element, pencil case is a set. Empty pencil case is considered an empty set. Can I place the empty pencil case in your bag and go on to say that the elements found inside your bag are not affected? Is that true? True, right? Do you agree? If I put empty pencil case in your bag, the total elements in your bag still remain the same. So that means to say that the presence of an empty set inside any set has no effect. Hey, very important. So, in summary, the empty set is always found inside any set. I can easily put it anywhere I like, precisely because it is empty. It has no effect on the set that I am placing the empty set inside. If you need some time to process this. If you process it properly, it will stick with you. If you cannot, you really want to give up already, then you just need to memorize one thing. The empty set is a proper subset of any other set. Okay? If you cannot take it out, you just want to memorize, take the easy way out. The memory work is that the empty set is a proper subset of A. Now we move on. The universal set. So we talk about your bag being set A. What could a universal set be? A universal set could be this classroom. Inside this items inside this classroom. Your bag is found inside this classroom. Her bag is found inside this classroom. That is the universal set, assuming the bags cannot leave the classroom, okay? They have to be found somewhere. Every single set has to belong to a universal set. There is always a bigger set called a universal set. Okay? And because it is the universal set, everything must be found inside already lah. And therefore we have the second property. Every set is found inside the universal set. Every set is a proper subset of the universal set. So if you cannot take that, you need to memorize, then you just memorize this. Okay? Okay, so example number 9, we have the universal set. Okay, x is an integer, but there's a restriction. It is not just an integer. We've got x ranging from -2 to 4, inclusive. So we've got -2, -1, 0, 1, 2, 3, and 4. And then set A are values of x such that 3x plus 1 is greater than 6. Set B is 5 minus 2x is less than -3. So list the elements in set A. That we've done it already. List the elements in universal set. So universal set, This is what I just said. And then for set B, set A, we go on to solve the inequality first because we are trying to find out what elements it contains. So we solve the inequality and we get x is greater than 5 over 3. X is greater than 5 over 3. Wow, there are so many, there are infinite elements, right? Sounds like it. I've got 5 over 3 is how much? 1.666, right? I've got 1.7, 1.8, so on and so forth. However, you have to recognize that, universal set. The universal set only contains from -2 up to 4 only. The universe only has -2, -1, 0, 1, 2, 3, and 4. I cannot have 1.7. I cannot have 1.8. I only can choose from the universal set. So based on that, I only have 3 options, 2, 3, and 4. Okay? So question, is B a proper subset of A? B. So we need to solve set B first. B, turns out x is greater than 4. Then we compare this with, for set B, x is greater than 4. Actually, there's nothing inside what? Because for x greater than 4, we need x equal to 4.1, 4.2, so on and so forth. But our universe only stops at 4. So actually, our set B contains nothing. There's nothing inside set B. So we say that B is an empty set. Since the empty set is a proper subset of every non-empty set, so this is the one that I wanted you to memorize, it therefore implies that B is a proper subset of A. An empty set is a proper subset of any other non-empty set. Okay, now these are homework questions. Question 3, 5, 6, and 10. 3, 5, 6, and 10.